The last example we have here is showing how you can get the same data from functional mode versus parametric mode, and how parametric mode makes it a little easier to interpret the data. So first of all, I've got two equations here in functional mode. The first one is a hawk. The second one is a dove, where t is measured in years. So the first thing we want to do is we want to plug each of these into functional mode. I'm giving you a lot of hints right here in terms of the window size, but really y1, we'll set y1 to be the hawk. And instead of t's, we're going to have x's. So negative 10 cosine of pi x over 2 plus 20. And then for y2, we'll plug in 100 sine of pi x over 2 plus 150. So if we draw a quick sketch of the graph, there's what I've got entered into my calculator, and I'll hit graph. And I can see right there I get two sets of curves, one being the dove and one being the hawk population. So let's do a quick little sketch. Looks something like this. Not perfect. But I want to find the maximum and the minimum for each of the populations. So for dove, we're going to want to find a max and a min. And for the hawk, we're going to want to find a max and a min. So if I take my graph, let's do a calculate of the maximum. I'm going to go up here to the maximum here, and we said this one is going to be the dove population. So I'll do a left bound, right bound, estimate at the top right there. And I can see that my maximum is going to be 250. So the maximum for the doves are going to be 250. Let's do the same thing second calc and calculate a minimum for the dove. So right about there is the minimum. And I can see my minimum for the dove population will be 50. Do the exact same thing with the hawk line, and you'll see the max is going to be 30 and the minimum is going to be 10. Now what we're going to do is we're going to go to parametric mode. And what I had up here were the parametric equations, since these are both with respect to t. So we'll let the hawk be x of t. And if we let the hawk be x of t, negative 10 cosine of pi t over 2 plus 20. And I have the dove, will represent the dove as y of t. That's going to be 100 sine pi t over 2 plus 150. So let me go to my mode. We'll go parametric. Delete my previous problem. And we'll plug this in. So we said hawk will be x of t. So negative 10 cosine of pi t divided by 2 plus 20. And then y of t we said was going to be the dove. So 100 sine of pi t divided by 2 plus 150. I give you some hints right here that we're going to set the window to t min is 0, t max is 5, t step is 0.1, x min is 0, x max is 35, x scale is 5, y min is 0, y max is 300, and y scale is 50. So if I hit graph now, my new picture is going to be the circle that appears. Let's just trace around the circle and see what happens. When I get to the top, I see 250. When I get to the right, I see 150. I see 50 for the y's there, and I see 150 right there. So let me plug in each of these values. So the side of the circle here is going to be 10 and 150. If I scroll to the top, I'm going to get 20 and 250. And if I head back around, I'm going to get 20 and 50. And if I go over here, I'm going to get 30 and 150. Now, how do those values relate? Well, we said that up here the dov max was 250 and the dov min was 50. So you can see right here 250 is the max on the y, 50 is the min on the y. So that means right here we're looking at the dov max and the dov min, which makes sense because I was talking about the dov being in terms of y of t, so I'm looking at the vertical pieces. The horizontal extremes, 10 and 30 for the circle, represent the Hawk minimum and maximum. So over here we've got the Hawk minimum, and over here we've got the Hawk maximum. So this equation is just another way to represent what I do in rectangular form. The height and the width of my circle, or those x and the y coordinate extremes, give me my maximum and minimum of the dov population.